Hello, welcome to the examtime.com. Today I am covering you MySQL in 15 minutes. The agenda of the presentation is we'll start with the introduction. We understand the query types. We understand the importance of the data dictionary. We enhance the performance using the indexes, and we come up with the data consistency using the database constraints, and we understand the concurrencies using the isolation levels. DDL stands for data definition language. Create, alter, drop, truncate, create a select comes under DDL. DML, data manipulation language. Insert, update, delete, insert as select comes under DML. Query language, which is select statement, which comes under query language. Commit and rollback comes under transaction control language. In a transaction, database transaction, we need to commit or rollback. So DDLs do a auto commits, and DMLs can be committed or rollback, and query language doesn't need any commits or rollbacks. For simplicity, we use the employee table and department table from Scott schema. And we start with the simple select employee name from the employee table, or select employee details, all the employee details from the employee table. And second option is filter, whether you filter only required employee details. For example, select the employees who work in location Hyderabad, and next option will be order by their join date of joining, or order rank by their salaries. Important thing to remember is if you are doing order by, it might read file sort, so the performance can impact using order by or rank. Next operation is set operations, which includes union, all, or intersect, or minus. So consider a scenario, you have two employee tables, which is for EMP_US for US related employees, and EMP_India for India related employees. And you want to combine the results from the two select statements, select star from employee, select employee name from the employee US, union or intersect, select employee name from EMP_India table. Intersect looks for the common records, union all records allows duplicate, union distinct will not allow any duplicates. Minus is not support in MySQL. Coming to joins, you need to join one or multiple tables to get some results combined with other tables. For example, you want to get an employee name and department name. Employee name comes under EMP table, department name comes under department table. Those are joined by primary key called department ID, which is in department table. So you have to join employee, and in order to display the employee name and department name, you have to join employee.department ID is equal to department.department ID. You have to join a equi-join. Sometimes if the employee does not belong to any department, even though you want to display him, you have to do a left outer join, so that irrespective that employee have any matching department or not, it will be displayed. Left outer join, right outer join, left right outer join. You have other scenarios as well. You want to group by certain columns and do a aggregate functions on the some of the other columns. For example, you want to group by on a column such as location, job location, and employee job location. You want to group by, and you want to sum up the salary. So that you can know every location how much salary we are paying. A HR department can find out in a employee location wise how much salary they are paying, or how many employees present, count star group by location. So for that purpose we can use the group by, with having also it is possible. Sometimes single query might not be sufficient. You have to get some of the filter criteria or some other details from the subquery. So main query, it depends on your subquery results. So subquery performs can be independent of the parent query, main query, or it might be dependent on the main query. For example, in a scenario, you want to find out employees whose departments are located in China. At that time, you have to select from employee where department ID in. You have to write a subquery, select department ID from department table where location in China is equal to China. So you will get all the departments in the subquery and given to the main query. So that is called subquery. Whereas you have a dependent subquery, correlated subquery, parent table column involved in the child subquery table join. So it is similar to a join, but it's just similar like for every parent column, this subquery will be fired with particular values that you joined in the correlated subquery or dependent subquery. For example, you want to find out what department is not having any employees. In that scenario, you will be selecting on the department table as a main query, and you are joining uh, on exists or not exists using the select on the subquery with the employee table where employee dot department employee dot department ID is equal to department dot department ID. If it does not exist, then only you want to display that department. So so in this query, your correlated subquery, you have a column involved in the with the parent or main query. So that is called correlated subquery, which might not use any index for the join, or index match is not used. And you can also have a query using a derived tables. So whereas you have a select query which operates on a different select query, which select query might be on a single or multiple tables, but you have a outer select which is acting on a another select, that is called select using a derived table. So MySQL will create a temporary table on it. Sometimes derived table performance also very slow because in older versions you don't have options to create indexes on the derived tables, and you also you can have merges on the derived tables. When you join on a table, instead of a specific table, you can write a select query and you can join. So in join or select based on a derived table, temporary table. Temporary table is nothing but you have alias when you write a select query, where that can be attached given to a select statement, or you can join to a another table, parent table. Coming to the data dictionary, you assume some scenarios, someone asked you to find out what are the tables involved having SSNs or credit card information. So you cannot go to each and every table or column and find out all the columns whose data is SSN or credit card number. So you can have a like a information schema dot tables or columns and find out whose column is like percentage percentage SSN percentage, so that it will give you the all the columns which have anywhere in SSN or CC credit card, something like that. So it is easier to analyze your data dictionary and do some actions, take some actions. Consider a scenario where you don't know the what are the child tables, what are all the child tables, but you are updating in a parent column. So if you don't know you can't go to every other table and check the foreign keys exist with that primary key or not. So instead of that, you can do on the information schema dot table constants where you have you can give the constant name what are the where are the places this constant is used. And sometimes you want to, when you are doing a query performance tuning, you can do the find out what are the indexes the table is having, and what kind of indexes it is, and how many columns are involved in the index. And you can, so that you can force or you can ignore the other indexes. You can give the database hints to the MySQL. Coming to the triggers and views, you can also find out the what are the triggers available on what columns, one table, what tables, and what are the views available on which tables. You can find out all the details using information schema dot triggers and views. These are all comes under MySQL data dictionary views. So which is very important. You can utilize that. That will be very great. Indexes are very essential if you are when you are searching for some of the records in the database. It speeds up the search, which improves the performance, reduces the less I/O to the storage files where the data is there, and the search when you are doing select query using a where class or order by or join, you need to check whether these columns are having any index and you are using that index or not. Specifically, the data structures involved in the indexes is either B tree or hashing or other data structures, bitmap. There can be other data structures as well. Whereas the hashing, if you MySQL does not provide inbuilt hashing, you have to do your own columns of hashing. Hashing will work if you are using a either it is a equal scenarios, equal, whereas B tree it works fine for all the other scenarios like range, not exist, all this in class, all these kind of cells that B tree is well suited. Whereas covered index, all the columns involved in the select class, where class, order by class, if we have the combined index using the covered index, then one or two index that is called covered index. So you don't need to look into the IO, which is data files, so which speeds the your performance, query performance. And combined index, whereas you need to sometimes you need to create index on more than one column for the better performance reasons. For example, take a scenario where your employee table has employee ID and department ID. You want to create index on that both of the columns because you are using where employee where department ID is equal to this and employment name ID is equal to this, something like that. Normally employee IDs will not allow duplicate, so you can take other scenarios like employee name and department name, like that. So the scenario whenever you need to create multiple combined index, so then for example assume that your employee IDs are duplicated in the employee history, and you have employee ID and department ID is a combined index or primary key. Then the primary key first column in the combined index must be on the department ID. Only then you can use the employee ID in the as a next second column. You can force the specific indexes to be used, or you don't want any index to be used at all. That is comes under full table scan. Full table when you need, if your select query is returning more than 50% of your results in the database, then you do, if you are still using your indexes, your performance might be very slow. So they at that time you have to liberate, you have should not use any indexes. You have, it's good to go with the full table scan. So it's not always recommended to go with the indexes, but you have to see which cases we need to go with the indexes or not. You have the database hints which you can do to for either force a specific index to be used in the query performance tuning. Thank you everyone. Hope you all enjoy this session, and next session I will cover the